Good afternoon. I'm Emily Manderson, and Julia, Raish, and I are going to speak today about UT as an ecosystem, and we're environmental designers at the Lady Bird Johnson Wildflower Center. So as you can see here, there's an aerial of UT and its surrounding context, and it's nestled within an urban fabric. The landscape makes up mostly impervious cover, and there's some street trees as well as some vegetated areas. And there's been an increased attention on the campus to improve sustainability through LEED certified buildings and incorporating native plants into the landscape. But these alone don't provide enough ecological performance. If we saw UT as an ecosystem, we could greatly increase that. So what is an ecosystem? An ecosystem is actually not a linear process. It's multivariate, it's dynamic, and there's energy flows at different levels in between the system itself, and then also there's inputs and outputs into the surrounding context. So an ecosystem also has benefits that it provides that we're dependent upon for our survival. An environment where the ecosystems are at its most highest service is in a more pristine environment. So as you can see here in the green field, the ecosystems are pretty much doing the best that they can do. In a gray field or a brown field, the ecosystems can be improved. And this is an opportunity where we can come in and increase those, and they're also in areas where we need them the most. Ecosystem services can also be measured and monitored, and this is the basis of the Sustainable Sites Initiative, which is a voluntary rating program for landscapes, and it defines a sustainable landscape as one that has high performance.
One method to get measurable benefits in the landscape is using the technique known as low impact development, or LID. LID is it's a stormwater management tool, but it's also a comprehensive approach to site planning, design, and pollution prevention strategies. And when these are all combined, they create a more economically sustainable and ecologically functional landscape. LID works with nature to treat stormwater as a resource rather than a waste product. And it allows water to be managed in a way that reduces the impact of built areas and promotes the natural movement of water within an ecosystem or a watershed. Potential technologies include those tools that filter and infiltrate stormwater in a distributed site-specific manner rather than the conventional centralized pipe and conveyance system. This also provides opportunity for captured water to be used throughout the landscape for irrigation, ornamental features, drinking water, or even groundwater recharge. And when designed appropriately, LID is a tool that can be used in any ecoregion, climate, or land use typology. With this in mind, UT has the opportunity to implement LID on the main campus to provide valuable ecosystem services. While there are dozens of campuses across the nation that have already taken this initiative, I wanted to just take a minute and show some examples from various ecoregions and climates. First, we have Portland State University in Oregon. Of course, this Pacific Northwest area has become a bastion for LID technologies, both on college campuses and throughout the city. We also have LID technologies in the Mid-Atlantic region, on the University of Maryland in College Park, and even in the arid Southwest at the University of Arizona in Tucson. And what's interesting to note on Maryland is that they wanted to integrate LID into the campus landscape while maintaining the same formal aesthetic and maintenance regime as existed prior. And closer to home, we have the University of Texas Arlington campus, which has this new project which incorporates many LID tools and techniques in what's called a treatment train approach, where you can maximize the benefit of these ecosystem services by having multiple tools. So on this site example that's shown, there are rain gardens, roof capture systems, and a large detention area that treats stormwater runoff from a parking lot that doubles as a usable lawn area. And due to the urban nature of the UT campus with dense footprints and high impervious cover, we think that the ecological function of the campus can be greatly increased by implementing LID on site.
While these are all excellent examples of increasing ecosystem services, they would function much better if they were analyzed and systematically, rather than treated as individual projects that often are plunked into the landscape. So we developed a methodology for looking at the most ideal locations for LID in the San Antonio watershed. And we looked at 7 different inputs. We looked at just a few of those were the location within the aquifer, the impervious cover, and the soils. And we propose that something like this could be done at the University of Texas on the campus here. And if we took just a hypothetical location and said that this could be a high priority area, and we said it would be the Student Alumni Center next to the campus, to the football stadium. And we chose this one because of its proximity to Waller Creek, which is a riparian resource here on campus. As well, it has a busy road, and that is for retrofits. It's a lot easier to put in LID, and then also it's a source of pollution, and it's high visibility. It offers an opportunity for education and awareness.
Because LID is a fairly new practice, we also see that there's great opportunity for UT to become a leader and an expert in the field. First, there are many LID components still under debate. A lot more research is needed on many components of the technology, such as the biofiltration media, and whether, for example, as this slide shows, we could use locally reuse local recycled materials as well as mined materials such as sand and peat. Second, there's a need for monitoring on these real-world features. Acquiring monitoring data affects future design and implementation, both for this campus and off the campus. But most importantly, implementing LID has broad educational opportunities across the campus and could involve varied disciplines from architecture, natural sciences, engineering, the McCombs Business School, and even communication and education. And most beneficial would be to have a transdisciplinary process where each of these disciplines are working together to inform and strengthen each other. And including students in the research, the assessment, development, monitoring, and maintenance of LID can provide great benefit to UT through scientific discovery and provide valuable real-world data for longer-term sustainability research.
And the beginnings of LID are starting to appear on the campus, and they can be increased by looking at them through a systematic approach. And with LID in place, the thing about it is that not only are they helping ecosystem services in terms of water quality, but they increase ecosystem services in terms of habitat function, thermal regulation, carbon sequestration, so you have a layering of function. As well, if you had these systematically placed throughout the campus, they could then communicate to one another and act as meta-populations. And then they could also function and communicate to other sustainable features and even communicate beyond the boundary of the campus. And this offers the opportunity of University of Texas being a model to not only the students, but the community at large, and while improving the quality of life and a sense of place. Thank you.